Welcome. So we're a little ways away, a couple weeks in. Let's get to it. This week we're going to talk about loops. Now there's three different loops you need to know about in computer science. The first loop is for loops. These loops actually iterate using a set amount of times that you iterate through something. And you have to tell the loop how many times you would like that to iterate. Then you have do loops and while loops. Do, while, while. So what is a while loop? We'll start with that one. A while loop is a loop that has a Boolean expression inside of it. And that Boolean expression tells the loop whether or not to run. And as with an if statement, if that Boolean expression is true, run the body. And then go and check that Boolean expression again. If it's still true, run the body. And then check the Boolean expression again. That's how a while loop works. It checks the expression first, then it runs the body. In a do while loop, we have something a little different. It's a while loop backwards. A do while loop does the opposite. What it does is it runs the body first, then it checks the Boolean expression to see if it's true. If the while expression is true, it goes back and runs the body again, and then checks the Boolean expression again for the sentinel value to see if it's true. And it keeps doing that until the Boolean expression is false. These are the three main loops you will find in computer science. So let's go over loops and let's see if I can do a little brain dump on Python loops. Here we are. Loops, 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 and I'm done. All right, so I know everything there is to know about Python loops. Let's get into it. So let's talk about for loops. First things first, what I want to do is I want to create an environment that can run a for loop. So let's get rid of what we did last week. And let's create an array. We're gonna use a very simple array that calculates prime, or that prints primes. So in this case, I'm gonna say primes equals 2, 3, 5, 7. Now, the loop you're about to see is a variation of a for loop. In PowerShell and C#, for loops have a evolution called for each. And what the for each loop does is it says for every element that is in an array, I would like you to run. And when there are no more elements in that array, don't run anymore. That's a for each. A for each is an evolution of the for loop where I don't have to define how many times I want the for loop to run. It just runs until there's no more objects left. So for prime, and what's prime? In this case, prime is a variable. I know I didn't initialize prime before this, and I don't have to. I'm initializing prime in the for loop. In primes, what's primes? Primes is the array that we created. Now, for those of you who are looking at this array and going, what are you talking about? An array is nothing more than a variable that contains more than one value. Now, that's a very simplistic way of explaining it, and I really don't want to confuse you any more than I'm about to. Just understand that if I had an array, or if I had a variable like prime, and I said I want a prime to equal 2, the only value in prime would be 2. But because in this case I have an array, the array can hold more than one value. So if I said I want what is in the first position, what would I get? Let's see. Now some of you might be saying you're going to get 2 because 2 is in the first position. I dare say that is incorrect. I'm going to get 3. Oh. Print prime. No. Yeah, print prime 1. What's wrong? Prime is not defined. Prime isn't defined. Primes is defined. 3. So, why did I get 3? Because in computer science, everything starts at 0. We don't start counting at 1. That's a human thing. As a matter of fact, in most algebraic languages for computer science, calculus, things of that nature, we all start counting at 0. So what's at the 0th position? 2. So if I wanted to get the value that's in, or if I wanted to get the number 7 that's in this array, what position is it in? It's in the 3rd position. And I get 7. Okay, so let's get back to for loops. The reason why I explained the array so you understand the for loop a little better. So for prime, remember prime is a variable that I'm initializing in the for loop. This for loop in this line right here that I'm creating, prime is being initialized, so it'll exist. In primes, which is the array that we just created, I want you to print all the things. Now, why didn't I say print primes? Because every time this iterates, what's going to happen is it's going to check primes at the 0th position first. It's going to take that value and place it into prime. Now, prime is whatever primes is at the position that we are in the iteration. And right now we're at the 0th position. So basically what primes is right now here, in effect, is prime 0. When this iterates again, it'll be prime 1. When it iterates again, it'll be prime 2. And it'll keep doing that until there's no more values in primes. But I don't have to say primes 2. All I have to say is prime. And every time the for loop iterates, it'll look into the variable of prime, or it'll take whatever element, whatever value is sitting at that position in the array and put it into the variable prime. And then I can manipulate that variable in the for body. So let's run this and see what I get. And I should get 2, 3, 5, and 7. And as a matter of fact, that is exactly what I get. This is one of the most simplistic loops you will ever use. And if I'm not mistaken, it'll be one of the most used loops you will see. So let's go a little further. Let's say I wanted to do a sequence on something. Let's say I wanted to sequence only a certain amount of these values in this array. So I can say for prime in primes, or I can say in range, and then I can print. Now we're not going to go there. It's a little more complicated. I'm not going to confuse you. Let's jump right in, and this is for loops simplistically. Let's jump right into a while loop. So I'm going to save this as for loops, for loop example. We have a while loop example. So what's a while loop again? A while loop is a loop that runs after a Boolean expression has been validated as true. Now, the problem with while loops is that there are no counters in while loops at all. So if we wanted to count something, we would have to create our own counter. In for each loops and for loops, normally the counter is created in the loop. In Python, the for loop is written a little differently than it is in other languages. In other languages, a for loop was written like this. For var I, and it's not going to validate right, so just bear with me here, equals 0, I being my counter, and then I can control what I is. So I'm telling I to start at 0. And then what I want to do is I want to iterate on something. Obviously, primes is what I'm iterating on because that is the array that I want to print or manipulate. So what I'm going to do is, and this is another language. Let's say this is C#. If I can type JavaScript, Java, all of the languages, etc., they do for loops this way at its bare minimum. And as long as I is less than the length of the array, so I'll just say primes length I++, which means iterate that I by 1 at the end of this iteration. So for a loop will run, it'll run the body, and then at the end of the body, it'll iterate I by 1, meaning that I will be my counter. And then in this case, I can say, and once again, this is not Python, this is another language, I'm just showing you what it would look like. Print prime. Now, why am I showing you this? Why is this important? Because in most other languages, for loops have a defined counter. I, in this case, is the defined counter. So I wouldn't say print prime. What I would say is print primes I. Why? Because I is my counter. I is iterating every time the loop iterates, right? So what's going to happen is I is going to change until there are no more elements left in the primes array. This is how a normal for loop is written in other languages. This is why I just said earlier, while loops don't have counters. For loops do have counters. In this case, for the for each that we have in Python, I'm going to erase this so I don't confuse you any further. If I can. Why is it doing that? Fine, there we go. For the for loop, this right here, that we use in Python, for prime and primes is a for each loop, meaning that for each item that is in primes, I want you to do something to the item. And what will happen is the for loop will take that element at that position and put it into the variable that you decided it to be named. So in this case, I don't have to name this prime. I can name it number, and it would work just fine. I can name it anything I want. And there you go. It worked. Because this is a variable. That's all it is. It's a placeholder. So what will happen is for loop iterates. Primes takes the first, puts it in number. I can do something with number. Okay, let's jump into the while loop. So let's use the same primes array, and let's say let's iterate a counter or an iterator. Count equals 0 while count is less than 2. I know I just did the Stevie Wonder there. Print count. Now I'm going to go out on a limb here and hope that this works. This may not work. It didn't. All right, so there's no... Okay, so what I just tried there is I tried to use the increment assign operator that we normally use in other languages called counter plus plus. And what that essentially means, what counter plus plus means, or what counter plus equals 1 means, is this. Counter equals counter plus 1. Now, counter plus equals 1 means the same thing. But why would I do counter plus plus instead of counter plus equals 1? It's shorter. In this case, counter plus equals 1 could be anything. It could be counter plus equals 5, and it would be counter equals counter plus 5. But normally, the reason why we do counter plus plus is because the iterator of that shorthand can happen either before or after that line runs. Very important. Not going to get into it because this is not Python. But just letting you know it can happen. In this case, I just want to increment my count by 1. What's going to happen? Are all the values in primes going to print? No. I'm not getting... why did I get 0 and 1? This ran. All right, so ignoring this... Okay, let's try that again. And actually trying to... I don't have any... If I was smart, I'd just copy that. There we go. All right, instead of saying print count, I want to print primes count. What did I just do there? Well, let's run it and see what happens. I'm not going to get all the numbers. I'm not going to get 5, and I'm not going to get 7. Because once count equals 2, it's not going to run anymore. So it's only going to run twice. What am I asking for in my print statement? I'm asking for the primes array at the position that the number count is. So the first time this runs, what is the value of count? 0. So what's going to be put here? 0. What did we do earlier? What comes out, what comes out of primes when it's at the 0th position? 2. It's going to iterate again. Now count is 1. Right here, count will equal 1. It's been assigned the 1 number, the 1 integer. So primes at the first position is what? 3. It's going to iterate again. Now count equals 2. Is this going to run anymore? No. Because once count equals 2, this is now false. Because this can only run when count is less than 2. And that's the way that works. Let's take this a step further, though. Let's talk about something that I alluded to yesterday. Let's say that we had... I don't know. Let's say we had a situation where we wanted the loop to stop before it was supposed to stop. What would I do? Well, in this case, I can say print count, and let's add a little jazz to it. If count is... I'm so used to putting brackets. If count is equal to 1, break. And I'm going to say this is less than 4. And let's run it and see what happens. As a matter of fact, I want... Yeah. Yeah, that's actually what I want. To put this before you. And that's good. Let's run it and see what happens. 2. Now, why did I only get 2? What happened? Well, let's go over what happened inside of the loop. Count equals 0, while count is less than 4. Is that true? Yes, because count equals 0, and 0 is less than 4. Print primes 0, because count equals 0, so I get 2. Increment count by 1, and then check the if statement. If count is assigned or equals 1, break. Is count equal to 1? No, it's equal to 0. Keep going. So count now equals 1. While count, or 1, is less than 4, is that true? Yes, it is. 1 is less than 4. Print primes count. Count plus equals 1. If count equals 1, now I made a mistake here, and I hope you guys caught that. That loop would have never run. Let's go back to the first loop and try again. Count equals 0. This is our first loop. While count, or 0, is less than 4, I want you to print what's at the 0th position in primes, which is 2. Increment count by 1. Now I want you to check to see if count equals 1. Does count equal 1? Break. Well, count does equal 1 because count incremented by 1 in the first loop. So what's going to happen? It's going to skip the rest of the loops. It's going to stop running. It's not going to run anymore. The same thing is true, or not the same thing, but there's also another use. We can have what's called continue. Now, what does continue mean? Let's say print. Let's do that. That's not what I wanted to do. Give me 1 parsec. Good to go. So, print primes count I put after that count. What's going to happen? Let's run it. I get an error. Why did I get an error? Index is out of range. Interesting. Why did it do that? Ah! Got it. So, we got 5 and we got 7. We didn't get 2 and we didn't get 3. Why? Well, while break means I want you to stop doing what you're doing and go to the next line, meaning stop the loop altogether and move. What continue means is don't run anything after me. Just go to the next loop or go to the next iteration. Continue skips the current iteration and goes to the next one. And as you saw, it skipped 2 and it skipped 3. I'm unsure why it skipped 2, but it did skip 3 because count equals 1. Interesting. And then it told me that it was out of index, which is also rather, because I have too many. Well, that's interesting. Okay. Normally, we don't use continue. We use break. And the reason why is because sometimes you just want something to stop because you don't want it to do what it's trying to do if something else is true. Now, let me ask a question. Can you do something a little cheeky? Can you make a for loop or a while loop do something else if it's false? Can you? Well, actually, the answer is you can. So, let's put this back for a second. This is the way we had it before. When count equals to 2, I'll say 2 this time. I want you to break. Let's see if it works. It does. 2, 3, it doesn't count. It doesn't do 5 because at that point, count equals 2 at that point, right? Okay, we understand this. But let's say I wanted something to happen afterwards. Else, looks like we have too many elements and primes. What's going to happen when that break fires? It's going to leave the loop, but it's going to enter the else bracket. It should, at the very least. Let me see what I'm doing wrong. Let's try this instead. All right, and then let's not do the break here. I'm going to save this break for that for loop. Now, because break means just stop what you're doing. So let's do this. Count value reached 3. So what essentially happened is when it reached the 3rd, and I actually don't really like that, so I'm going to change it again. Run. Okay. There are 4 elements in the array. 0, 1, 2, 3 positions. 0th, 1st, 2nd, and 3rd positions. When count, because there's 4 positions being filled, I want to stop it when it reaches 4. At this point, I'm printing all the counts, all the prime elements using the counter, and then I'm incrementing by 1. When this while loop is false, what's going to happen? Well, when an if statement is false, what happens? Well, the else fires. So, when the while is false, what's going to fire? The else. Now, this is kind of redundant because you really don't have to do this. You can just do this. And it does the same thing. But let's say you did want an else clause in there to catch some exceptions or whatever the case may be. You can put it in there. Let's put that back. What about the for loop? Let's take the for loop, shall we? Let me see if I can... in Visual Studio, you can toggle comment. That's wonderful. All right, so now what I want to do is I want to untoggle these comments. Uncomment, please. Toggle. Oh, wow. Uncomment? Oh, because I've already commented it. Interesting. And I actually want you commented. There we go. All right. We have our for loop. Let's make it go to an else statement. Else. And let's type in here that break we were trying to type before. We don't have a count. So let's say... if number equals 5. No. 7. Break. Else. Print. Let's run it. It still printed 7. Oh, right. Let's do 5 instead. I know why that happened. 5. But the else didn't run. Why not? Something's wrong. What did I do wrong? Or not. I believe that the break is skipping the else. Maybe if I just didn't do this. Let's see what happens. Got it. So in both situations, you saw me do something and it was a big mistake. What you saw me do is break each of the loops. But once you break the loop, it won't run anything else that is attached to the loop. This else is attached to the loop, so it won't run. What you have to do is you can only use the else if you're not using a break statement. In this case, once the for loop was false, once it was finished running all of the things that were in the primes array, it then asked, is that really a prime number? Just for the record, you can add else statements to arrays. Or, to loops when the loop is complete or when their Boolean expression sentinel value has been reached. False. This has been very interesting. I hope this has helped you out. And as I always say, good luck. Ciao.